So now let's go ahead and summarize the rules for graphing two variable inequalities on a coordinate plane, in other words, an x and y axis, and how we show the solutions by shading in above or below the line to show where all the coordinate pair solutions, all the points that make the inequality true. So in each case, we want to make sure that we get the inequality into like y equals, in other words, slope intercept form. We're used to doing that. So like y equals mx plus b form, only we might have an inequality symbol instead of an equal sign. But we're going to get it into that form first. All right, so next thing we're going to do is think about, okay, when we graph that line, which is sometimes called a boundary line because it's sort of the boundary, it's the fence in between where the solutions are and where they are not. We're just going to graph a normal line, but if the symbol is not equal to, so if it's just a less than or just a greater than, we're going to use a dotted or dashed line. Right, so like a dashed line here to show that the points on the line are not going to be solutions to the inequality. But as soon as we say they're less than or equal to, greater than or equal to, then we just have our usual solid line like we normally would. So we just have a straight up solid line instead of the dashed line. Okay. And then we show where the solutions are by shading either above the line or below the line. So if it's a greater than, whether it's greater than or equal to, we're going to shade above the line. All right, so in that case, if it were like this, for example, we would be shading above the line. Okay. If the symbol is less than, like a less than or equal to, we would shade below the line. So if I had, for instance, a dashed line, so it was just less than, I would be shading below the line to show where the solutions are. All right, so let's go ahead and practice that down below here in the examples. So let's think about what this symbol would mean. So in this case, it's not equal to, it's a greater than sign. So that means that we're going to have a dashed boundary line. We're going to have a dashed line. And we're going to shade above, because it's greater than, to show the solutions. All right, so once we do that, now let's just think about, okay, our y-intercept is -4. So on the y-axis, that would be right here, -4. And our slope is +2. So slope +2, that means we rise 2 and we run to the right 1. So 2 is the same as 2 over 1. So we go up 2, right 1, up 2, right 1, up 2, right 1. That would give us a bunch of whole number values. And then we're going to make our line. Now remember, it's going to be a dashed line here. So we're going to make a dashed line for our boundary line. That means these points on the line are not going to be solutions to the inequality. But since it is greater than, that means anything above the line, so above the line sort of is like above and to the left here, any points that are in this area up here, any of these points, if we put the x and y values back into the inequality here for x and y, it would make the the inequality true. All right, so let's do the same thing with example number 2. So once again, let's look at our inequality symbol. So this is a less than or equal to. So in this case, since it's equal to, it's going to be a regular solid line like we normally would graph. And since it's less than or equal to, we're going to show our solutions by shading below the line. So shade below to show solutions. There's an infinite amount of solutions. We can't show them all. So we sort of shade below the line to show anything down here is going to be a solution. All right, so now let's just think back to our graphing. So we have a y-intercept value of 3. positive 3 on the y-axis, x-axis. And so positive 3, and this time we have a slope of negative 3/2, negative 3 over 2. So I'm going to put the negative sign up with the numerator. So that means from our y-intercept, we're going to go down 3 and right positive 2. So the negative part's going to be with just the negative 3, or the 3, the rise part, negative 3. Oops, sorry. Done that a couple times here. So then go down 3 and right 2 again. And that sort of takes us off the page down below there. So I think we have enough points to graph though. So again, solid line in this case. So we're going to make a nice solid line. And then all of our solutions are going to be below the line. So anything down here, any xy values down here, if we put them in for x and y in the inequality, it would make the inequality true.